We're looking at section 4.5 today. This is the last section before we do the first half of the chapter's test. All right. We are going to focus on two methods of solving. There are several, and we will hit the other methods in the second half of this chapter. But for today, our focus is on solving by factoring. We're also going to look briefly at solving quadratics by graphing. Graphing is a great visual. Lets you see what we're talking about when we find these solutions, but it's not the most accurate or the easiest method of the ones we have for solving quadratics. So typically we don't rely on it, but it is a good backup to check to see if what we're finding in our algebraic solution matches what we see graphically. All right, so the first picture you have here is a quadratic. The fact that it is opening down tells me what? There was some kind of reflection. Where would we see that in the equation? That very first term would be negative, right? You'd have some kind of negative x squared piece in there. All right, so we have this upside down parabola. How many places does it intersect the x-axis? In 2. What are they?
3.
At 3 and at 6? Okay. We have a lot of names for those points. We call them x-intercepts. What else could we call them? Anybody know the terms we've used? What is your y-coordinate at those 2 points? Y is 0. So we call them zeros. They are the zeros of our graph. We also sometimes refer them to them as the roots of our equation. But regardless of what we call them, the coordinates, you said this one was at 3, 0 and 6, 0. The coordinate for your y piece is 0 for both of them. So what we're looking at is instead of graphing a quadratic where we have y equals, what we're going to do algebraically is put a 0 in there. We're going to replace that y with a 0, and we're going to solve it algebraically. When we get our solutions, we are finding those x-intercepts, those zeros, those roots. So the answers that we come up with are really telling you where your graph should hit the x-axis. Okay? Now, because we have it equal to 0, we can use something called the zero product property. And that property says if you multiply two things together and get 0 for an answer, one of your things had to be 0. For example, if I say 5 times something is 0, I'm multiplying two things together, a 5 and an x, but my answer has to come out 0. That means x has to be 0. I could switch them around. I could say x times 2 equals 0. Dividing the 2 over, I still end up with x having to be 0. So it doesn't matter if it's in the first position or the second position. One of those factors has to be a 0. So our process today, we're going to take our quadratic, we're going to get it factored, and then either this first factor has to be 0 or the second one would have to be 0. We're going to look at what values for x would make that true. All right, so our first example, we have x squared minus 5x equals negative 6. Your very, very, very first step should be to get one side equal to 0. We cannot use the zero product property if we don't have it equal to 0. So our step 1, we moved that 6 to the other side so we could get it equal to 0. Step 2 is to factor it. Go ahead and take a minute, factor that quadratic. So what kind of factors did you come up with? X minus 2 is one of them. Somebody else? Okay. So we have it factored, and it equals 0. You're going to hear me say equals 0 about 50 million times during class today. Most common mistake as students move on in their math courses, they get sloppy about the notation. We don't want to do that. If we don't have it equal to 0 right here and right here, there's no way we can solve this. The most we could do would be to factor it, but we can't go any further without it equaling something. So you have to have on there equals 0. It has to be in this spot. It has to be in this spot. Okay? Our next step, we use that zero product property. Either this factor has to be 0, or the second factor has to be 0. And then we're going to solve each of those. So solving, we get x could be a positive 2, or x could be a positive 3. Our last step is to check those. We have to make sure and plug them back into the original equation when we do our checking. All right, so let's check the 2. That means that 2 squared minus 5 times 2 should end up being negative 6. Does that work? 2 squared would be 4 minus 10. That works? Okay. Checking the 3. Is 3 squared minus 5 times 3 equal to negative 6? We end up with 9 minus 15. Does that work? Okay. So they both work. We would include them both as our solutions. Now again, going back to the idea of graphing. If we were to graph this quadratic, we are saying that our quadratic, our parabola, should hit the x-axis at a 2 and a 3. Looking at our equation, our first term was just a 1x squared. So since it's positive, our graph should open up, and we should see something like this. Does that make sense? Okay. These next ones we aren't going to graph. We are just going to solve by factoring. Step 1 is always to make sure you have it equal 0. If you don't, move things around. All right, so first one here, what do we have to move? We have to move that negative 12 to the other side? Adding 12, okay. X squared minus 7x plus 12 now equals 0. Our next step is to factor. We can break up our x squared as x times x. How are we going to break apart our 12? We need a number that multiplies to be 12 but adds up to negative 7. 3 and 4. What signs? If we need a positive 12, the signs have to be the same, right? 2 positives or 2 negatives? Both negative will work. Check the paper to the right of your own. So at your table, check the person to the right. Do they have equals 0 on both of those steps? All right, moving on. We said each factor equal to 0. So my solutions are 3 and 4. Yes? All right. This side of the room, I want you to check the 3. Plug it back in the original problem, see if it works. This side of the room, you guys check the 4. All right. Did the 4 work? Did the 3 work? All right. We would put both down as our answers. The next one, is it equal to 0? Yes or no? Yes? All right. But it's only a binomial. How are we going to factor it? X squared minus 4x. Yes, we want to take out an x. That leaves me an x minus 4. Now I still have 2 factors. I have an x here that could be 0. That's going to be one of my solutions. And my other factor says x minus 4 could be the 0. In this case, x would have to be a positive 4. So my 2 solutions are 0 and 4. Do they work? 0 works? How about 4? Yes? All right. Our next question is one of our special pattern type factoring. What do we call that pattern? I heard a few people. What is it? Difference of squares. Yep. Difference of squares. When we factor the difference of squares, it means a perfect square minus a perfect square. And the factors look almost identical, except for what? One has to be positive, one has to be negative. So the 4x squared we're going to split into 2x times 2x. The 25 we're going to split into 5 and 5. And one is positive and one is negative. Does it work? Remember, you can always check that you factored correctly by doing what? By FOILing. Yep. All right. Set them each equal to 0. So 2x plus 5 could be the 0, and 2x minus 5 could be the 0. Check that your paper has all those equal zeros on it. Our next step, solve each of these. We're going to subtract the 5 over, and then divide out the 2. For the other one, we're going to add the 5 over, and then divide by 2. So I'm getting a positive and a negative 5/2. When we go to check these, remember you are plugging them into the original equation to see if it works. How do we square a fraction? Yes, square the numerator, square the denominator. So squaring a negative 5 makes it 25. Squaring the 2 makes it 4. You have 25/4 times 4. 4 times 25/4 gives us just a 25. 25 minus 25 is 0. So this one worked. Same with this one, right? Whether we have a positive or negative, as soon as we square it, it's going to turn into that 25/4. So I would include both answers. All right, I'm going to give you guys a few minutes. What I want you to do is solve the next 3. All right, we're going to check in periodically, but I want you to see if you can factor them correctly. Make sure they're equal to 0 before you start. Check in with the people at your table if you need help. All right, what factors did you get for this one? What did we come up with? Okay, the 3x and the 2x. The 3x plus 1 and minus 7. Are we okay with that? We agree? All right, then either the 3x plus 1 could be the 0 or the 2x minus 7 could be your 0. Solving each of these, we would subtract 1 and divide out a 3. For this one, we would add a 7 and divide out a 2. And again, we can plug those back in and check them, right? You can square fractions. You just get a different fraction. Square the numerator, square the denominator. All right, our next one. How did you factor that? You took a 2 out. Okay, what's left? Once we've taken that 2 out, what do we do with the x squared minus 36? It's another difference of squares, so, all right. Okay, double check that you still are putting those equal zeros in there. Now, for this one, we have 3 factors. There's a 2, there's an x plus 6, and there's an x minus 6. However, only 2 of the factors involve an x. This front 2 is a constant. It's going to be a 2. It's always going to be a 2. There's no way I can change that into a 0. So the only places that could possibly be my zeros would be these two. So x plus 6 might be the 0, and x minus 6 might be the 0. My solutions then would just be positive and negative 6. Okay? Now, if that front 2 had been an x instead, then it does get you a 0, right? But if it's a constant, just a plain 2, you can't do anything with it. First step on this one was to do what? All right. How did we factor it? Positive 13 and a negative 2. All right. Setting them equal to 0. Our solutions would be a negative 13 or a positive 2. Do they both work? Did you check them? No.
We should have.
We always check our answers, right? We should have, yes. You checked that the 2 works, okay? 13, negative 13 squared. You guys know your squares up to 15, right? Negative 13 squared is? What is it? 169. Negative 13 times 11? You guys have calculators, right? Can you check these? Then use your brain. If your batteries are dead, use your brain. All right. So we had 169 minus 143 gives us what? And that's what we were supposed to get. So they do both work. Do they always work? No. The reason we're having you check these is as we move on to solving even more complicated quadratics, there are things we might do in there that create extraneous solutions.
So during our homework, they'll always work?
During your homework, will they always work? I don't know. You're going to have to check and tell me tomorrow.
I'm just
All right.
take that.
Our last couple, we are going to look and compare them with a graph as well. It does say to solve by graphing, but again, we said that's not going to be our easiest method, our most exact method if you have to graph them by hand. But we are going to check to see if our solutions make sense.
When only one works, that means it's vertex, right?
His question is, if we only get one solution, we've been getting 2 answers. If we only get one solution, he said that's the vertex. Would that be right?
Yes. Maybe.
What do you think?
I'm thinking not. Your face doesn't look like it.
My face doesn't look like it?
Yeah. Well, people in the video can't see.
It's a good question.
Alright, so her face looks like it looks like a no, so just letting the video know.
Back to our question. If we only got one solution, does it mean it's the vertex? In other words, is there any way for a parabola to touch the x-axis in just one spot and it's not the vertex? We could have it like this. We could have it an upside down one, right? But if it's only going to hit in one spot, so the answer to his question, would that have to be the vertex? Yes. Now, is it possible to have no solutions?
Yeah.
Yes, we can have a parabola like this that doesn't touch it at all, right? Okay. Good question. All right, last 2 that we're going to solve. We are going to use factoring, but we're going to compare it to the graph. First step, we have to get one side equal to 0. So I'm going to add the 2x over here, and I'm going to subtract a 2. So we have 5x squared plus 32x plus 12. How many ways can I break up a 5? All right. So our only options here are 5x and 1x. To get a 12, I have a fair amount of options. I want it to be a positive 12, and I want my middle term to be positive as well. What kind of signs am I looking at? Yes, both of them are going to be positives. So factors of 12. We need to make a 32. Okay, I'm hearing 6 and 2. Where do you want the 6? All right. So outside we get 30, inside we get 2. Okay. Then we set each of those equal to 0. Now, can you watch up here for 1 sec? Most of you would look at the x plus 6 equaling 0 and be able to say right away x has to be a negative 6. Yes? Okay. The other one has 2 steps to getting our answer. I'm fine with you doing both of those steps in one. If you can look at 5x plus 2 equaling 0 and know in your mind, I'm going to subtract a 2 over, right, which gets me a negative 2, and then I'm going to divide a 5 over. I'm okay with you writing that in one step. Okay? So, graphically, we are saying that we should be hitting the x-axis at a negative 6 and a negative 2/5. Yes? Does the parabola open up or down? My first term is positive, so opens up. We haven't done any kind of reflection. It's going to have to look like this. Yes? Now, that doesn't help me know where the vertex is, but that's not what I'm looking for right now. I'm looking for those x-intercepts. Okay? Could we graph this on our calculator? Change that 0 to a y and type it in, y equals 5x squared, etc., and look at our graph. We should see it crossing the x-axis at these 2 places. Yes? Okay. Our next question. First step, getting one side equal to 0. So I'm going to add an x over, and I'm going to subtract a 4 over. All right. We do have a couple ways to split up a 4. 4 and 1 or 2 and 2. Can you picture one that would work? 4 and 1. Ways to get a 3, we just have 1 times 3, right? What kind of signs are we looking at? Why both negative? All right. For the C term to be positive, we need 2 positives or 2 negatives. For B to be negative, we'd have to have the 2 negatives. How are we going to make a 13? A 1 here, a 3 here? Does it work? All right. So we are saying that 4x minus 1 could be 0 or x minus 3 could be 0. Which means for the easy one here, x could be a 3. How about this one? What are your 2 steps? Add a 1 over and then divide a 4. All right. Our last question. It says, from the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras County in 1965, frog jumping competitions have been growing in popularity. The graph shows the function modeling the height of one frog's jump, where x is the distance in feet from the jump's start. Now that's a little different than the quadratic ones we've looked at in the past. We usually had time on our x-axis, and we were looking at how long the jump took. Now we're looking at total distance, horizontal distance that it traveled. In other words, how far from the starting point does it land? Okay? This is our vertical height. How high does the frog jump? This is how far does the frog jump. Okay? The first one says, how far does the frog jump? We have a spot here where the frog starts. Coordinates would be 0, 0. Okay? The frog is jumping from ground. We are back on the ground here. We are looking for this distance. So we need our x-intercepts. Even though this is a decimal equation, we are able to factor it. There is no C term. So how do we factor when it has a squared and an x? Take an x out. So we have, again, we're replacing y with 0, right? We're going to set it equal to 0. We're going to take an x out. So we have it factored. Either x could be 0, which is where the frog started, right, at the origin, or negative 0.029x plus 0.59 could be the 0. So we have to subtract the 0.59 and then divide. So what happens when we divide two negatives? Now, I want you guys to do this on your calculator and keep that answer in your calculator. Don't clear it. So take 0.59 divided by 0.029. Who's got it? $20.345? Is that exact? There's a whole bunch more. Okay, so we are saying that the frog jumps a little over 20 feet. This distance here is about 20.345 feet. Okay. The second question says, how high does the frog jump? Now we're looking for what point? What's this called? The vertex. We need to find the vertex. How did we find the vertex when we had it in standard form? X equals, yes, negative b over 2a. So the opposite of negative 0.59 is 0.59. 2 times negative 0.029. Sorry, it was a positive 0.59, so now it's going to be negative. So again, we have a negative divided by a negative. Should come out as a positive answer. What do you get? Again, keep it in your calculator. We were at 20 point something, right? Now we're at what? It's not 10.0, 10 point. Give me the decimals. Okay. Think about in terms of your graph. If this was 20.345, where is this going to be? Halfway between it, right? Between 0 and 20.345, using the idea of symmetry. So we also could have taken this and just divided by 2, right? That would have gotten us that middle mark. How do we find how high it goes? Go back to your picture. We know this right here is 10 point something. How do we know this? You guys have done these before. Plug it in. If we want the y coordinate at this x value, we just have to plug in that x value. So we're going to plug it back in. We had negative 0.029 times something squared plus 0.59 times something, right? We want to dump that answer, that 10.17, etc. We want to dump that in. You do not have to retype it. That's why I said keep it in your calculator. So type this in right now. Negative 0.029 times, and then I want you to recall your answer. To do that, you hit the second key and your little negative key. Should say ANS above it for answer. And that's going to dump that previous decimal in there. Then you can hit your square key, plus 0.59, and then dump that answer in again. What are we getting? All right. We get 3.00 something, right? So that means the frog jumped a height of about 3 feet and a total distance of about 20.3 feet. 3 feet. He covered a horizontal distance of 20 feet. He landed 20 feet from where he started. He jumped 3 feet high. Okay? Now, the question is, give me a reasonable domain and range for this. So let's talk about the domain. This particular frog jumped 20.345 feet in distance. Okay? Is it reasonable to say you'd have a frog that would go 100 feet? Probably not. 50? Even that's kind of high. I would say if we're getting an answer of a little over 20, a reasonable domain wouldn't be over 30. Okay? Now, if the frog jumped a total height of 3 feet, what is a reasonable range? Not just for this frog necessarily, but what would be reasonable? From 0 up to 4 or 5? Probably isn't going to jump higher than we are, right? Okay, so the emphasis today is going to be to solve by factoring. If you have to graph it, you can always dump a y equals in here. Okay, you could graph that and look for where y is 0. Okay? All right, there's your assignment.